So much. Hey everyone, it's so great to see you, all of you here. Welcome to my talk, Usable Security, Bridging Research and Industry Practices. And thanks for coming to one of the few talks that doesn't have AI in the title. But don't worry, we will get to talk about AI as well at the end of this presentation. You will not get away. So one thing you should know about me is that I hate passwords. I hate dealing with passwords. I hate creating passwords, changing passwords, and I really, really do not want to remember passwords. And today I want to talk about, well, how do we make security more usable and security better? And I will come back to passwords quite a few times and then to AI. So a bit about myself before we start. Um, I did my PhD in computer science at ETH Zurich, and my PhD was on usable security. And I consider it my mission in my career as well to make security usable. And throughout my 9 years at Google and then the 4 years at Snowflake as a senior engineering manager, I've always worked on security systems, either like end user facing or for enterprise customers or internal infrastructure that is used by internal engineers. And I truly believe that making them secure by default, that understanding how people use them overall and adapting systems to people's needs is very important and is the only way to be successful in security. I'm going to talk a bit today about some of the research I've done and then also about how I applied the learnings from my research in my work in industry. And one thing that I will highlight is a study for which I received the Impact Award from SUPS in 2024 for research on usable security advice. So let's get started. Well, I think all of you here know what is security, but I want to sort of level the field on what is usable security, what does that mean, and what kind of things can we do or do we do to make security more usable. And I'm going to then go into an example, a case study, the one for which I received the Impact Award, to show how do we do usable security research. And I will in particular emphasize what sort of methodologies did I use in that study, whether it's like user interviews, surveys, like the different ways to collect information and how do we think about this about research overall. I will then deep dive into some of the work that I've done in my industry life. So coming from academia and with the rigor of usable security research, I want to talk about how much of that is still relevant or applies in day-to-day jobs when you build systems and maybe you have different constraints, maybe you don't have the same time, bandwidth, or maybe you're dealing with different problems, with less fundamental problems and more execution problems. And I want to leave you with some practical tips and takeaways in the form of these are surveys that you can run, and this is how you should think about it. Or, what kind of tests do you do and when do you do them? And what are principles, general good principles of usable security that you can apply to your own system designs? And I think it would be, a big miss to not recognize that the world around us is changing, that AI is currently going, through a huge revolution, that we are looking at changing how we write systems, how coding, what the software engineering job looks like. And I think that has a profound impact on security as well and on usable security. And I don't claim to, have the answers for how to make security usable for AI. I think we barely understand what AI looks like and what's going to look like. But I do want to share some reflections and maybe some parallels on how we can apply that to the AI age. So let's get started. What is usable security? Well, it is an interdisciplinary field combining human-computer interaction and security engineering. And the idea is that we should design systems that are both secure and user-friendly. Because we can think as much as we want about cryptography and make things, bulletproof and secure, but if these systems are used by users and users either don't agree or understand with the security requirements, or they bypass them altogether because they are just too uncomfortable, then we are not going to end up with secure systems. And I do think that the proverbial example of like unusable security for many decades now has been passwords. And you can talk, to any non-technical user about passwords, and they understand the struggle and they understand the pain. And I think that it takes more than usability research to move the needle in such areas. So when I say usable security, many people think of it as a somewhat security paradox. And it's often, sort of presented as if you increase usability, then you have to lower security, or that they are at odds. And I do think that they are at odds in some situations, but not in all. I think good designs also make this system secure by default and make it, easy to use security systems. And for me, my passion for usable security has started during my PhD, when I was reading like tons of anecdotes, research papers on how people actually use systems. And one of them, my favorite one, was about a user that was asked to change his password, but he was already using his favorite password. And the system wouldn't allow him to choose a new password that is the same as one of the last N passwords he had. So what does the user do? The user changes the password N times until it's no longer one of the last 10 ones, and he's allowed to use his favorite passwords again. And I always thought, anecdotes like those were really funny and enlightening, and they motivated me to do more usable security research. In the era of AI, or in many other systems, we also see like less funny, less fortunate incidents where maybe the user doesn't understand exactly what he's giving permission to, ends up installing some AI agent that has access to everything, all their photos to sort of organize, and AI agent ends up deleting all the pictures, and it's irreversible. I've heard, recent stories like this. Some with the one that I remember had a happy outcome at the end because there was a way to time to reverse everything. But these sort of stories, they can be funny, but they can also make us feel that we have failed users when systems fail. So during my PhD, I spent a lot of time reading research papers. And a couple of them, well, more than a couple, have been really foundational to the field of usable security and to my own thinking about security and about designs overall. And I want to call out a few of them here because they really are seminal. And even if they are by now 20, 30 years old or more, I think they were published in 1999, I'm not sure right now, the principles and the lessons still apply, and I do still recommend that you read them today. So the first one, Why Johnny Can't Encrypt, was published by Alma Witten, and it was really revolutionary at the time because at the time people thought, well, users can't use PGP, it's their fault, they're not doing it right. And she sat down with users and she gave them specific tasks here, encrypt an email and send it, and watch how are they doing it and where do they stumble and how do they think about private key and public key or other concepts are confusing for them and doesn't match their mental models. And the next one, Users Are Not the Enemy, also had like a big, shift in my mentality that like, hey, you have to work with users, and if they don't use your system right or they fail at security, it's not their fault. Like, try to see how you can change your own system and then your own design. And one of the people that have really shaped my thinking around usable security is Professor Lori Krainer from Carnegie Mellon. And she went and looked at all the leaked password databases and looked at the most common passwords that were out there and created a security blanket. And the biggest numbers there or passwords are the most common ones. And I think that was one super artistic, but also such a powerful way to convey to users that, hey, your password is not safe. Because many times, like just explaining these things to users and the messaging to non-technical users is hard. And I thought that was a very nice and creative way. And another sort of metaphor that stuck with me and that I'm going to come back to throughout the story is her talking about security warnings and saying that security warnings are like, putting a warning sign there on the pavement. If everything was secure by default, if everything worked right, then pedestrians could just walk by, users could just use the system and not worry about it. But when we as engineers cannot fix those security issues or we cannot make decisions, then we add a warning and we ask, the user to make a decision when sometimes we have failed. And I think I'm going to come back to this as well, but throughout my work in industry, I got to appreciate much more how much work goes into making the pavement secure before you can allow the user to walk through, and you can afford to not show those warnings. So let's see some general usable security principles. I would say design things that are secure by default, so you don't need to show those security warnings, and you can allow users to just go by through their day and focus on their tasks and focus to where they are getting at. Align systems with users' mental models, and I'm going to come back to this a lot because I think that matters a lot. The way people think about security, it influences so much how they think about your system, how they use it, and it's even more relevant in the age of AI and AI agents, which are such new concepts, and it's so hard, even for experts to wrap their head around agents and their capabilities. And provide transparency and explain security warnings clearly. And there's a really nice study I'm gonna quote on that. And involve real users in design and testing from the beginning. And this last one is something that I can say, really applies in industry as well. All of them do, but the last one I do think it's very important. And it can lead to, cutting a lot of engineering effort that otherwise would have gone into building things that were not necessary, that you need to reiterate on afterwards. And throughout this talk, I'm also going to talk about the different type of research methods. So when I was in my PhD, we would do some type of papers or studies. They would be more explorative studies where we talk about, for instance, one of my research was on cloud usage. And when users put their data, their photos in Google Cloud, in Google Drive, on Dropbox, how do they feel about the security of those systems? How do they feel about the permissions, about who has the right to see their data? And we didn't always know what we are gonna find or what exactly to ask going in. But these sort of studies, they can be really powerful in sort of understanding things that you don't know already, that you don't know what to ask about. And that also reveals a lot of, work on mental models. And the good pattern, or a pattern that I have applied in my research, is that once you discover those things and you see what sounds interesting, then you can use surveys to quantify and to see, hey, was this just one user telling me this, or is this a trend? Does this trend apply more in Switzerland versus in India? And that's where surveys can really help you run studies at scale and compare the results and bring in that quantitative data. One other type of user study that I do think we do a lot more in industry, but it's done quite a lot in academia as well, is interface or usability testing, where you give people a concrete task, you're building a new system, and you're like, hey, let's see, can you authenticate with, I don't know, biometrics? Can you go through this flow and set up the right access controls? And that's a very powerful method as well. And you can use all of this at the different times, and they complement each other. And finally, one that is harder to do, but I do believe it becomes even more important with AI, is having longitudinal diary studies. Because many times the problem with maybe interface testing is, as a company, you invite users in the lab, maybe, you set up a very scripted session, and then they are able to perform the tasks you gave them, right? But usage over time also changes, and real world environment also change. And especially with AI agents, where maybe you get one response today, but tomorrow the agent learns something different about the user and is going to adapt, I believe longitudinal studies become even more important. So there I was. I finished my PhD. I was very proud of myself. And I went on a trip and I met someone and I was telling them about my work. And they asked me, well, Iulia, but what should I do to stay safe online? And I was stunned because I thought about it and there was no like easy answer I knew to give them. There were just so many things to do. And though I believed, many of them were important, like use good passwords, install updates, don't reuse password, use two-factor authentication. I I didn't know exactly in which order to put them or which one to mention first, if I can say only one thing. And I think the our world is complex, and we do rely on users to keep many things, do many security things, and it can be quite overwhelming, especially when you don't have time for all of those. So I embarked on a journey to see what to do to turn it into a proper study and see what do security experts recommend, what do they do, and what do end users do. And this is a paper we have published in 2019, and it was replicated since then. And I'm going to use this I'm going to go through the methodology and the findings. I do believe many of these things still apply today, though maybe one or two things will change with AI and with the introduction of passkeys. So typically when you do research in academia, one of the most important things to do before you start is to sort of come up with some research questions. And what do you want to study there? And so in our case, it was, how do experts and non-expert security behavior differ? And to get to that, we went to some security conferences, like Bsides, but I think it was Black Hat and another one. And we stopped security experts attendees and we said, hey, would you be willing to participate in a study? I'm just going to ask you a few questions. And so we talked to 40 security experts, and this was the kind of exploratory side of our study, where we just asked what are the top 3 things you do to stay safe online. And then based on those answers, we created 2 surveys. One that went to security experts, and we got 231 experts from around the world to take it, and had a lot more questions and ability for us to ask like quantitative data and ask about behaviors. And one that was almost identical, but it went to non-security, to normal users on Mechanical Turk and non-experts. And that allowed us then to sort of see trends and compare answers. We used Amazon Mechanical Turk, which I think is still very popular as a research platform. You can sign up for it yourself. There are a bunch of people who come there to take surveys and get paid, and they get paid a small, dollar amount for the time that they spend. And people use it for all sorts of questions. If you're curious about anything, if you need something like for work, it's a pretty cool one. And you can turn around the survey in like 1 or 2 days. You get answers very quickly. So in the survey question, we still had an open-ended, what are the 3 most important things you do to protect yourself online? But then from those responses that we had gotten at the security conferences during the interviews, we could also identify the top 20 pieces of security advice that were mentioned, and then ask about each one of them. Do you follow it? How effective do you think it is? And for non-experts, how likely would you be to follow it, to do this if you heard that it is effective? So we wanted to see current behavior, but we also wanted to get to like perception of like how effective the advice is and how willing they would be to follow it and why not. And I think throughout our, one of the things that we have truly learned throughout this research as well is that if people, you can be the biggest security expert in the world, but if you tell people to do something and it doesn't make sense to them, they're like, how is this going to make me more secure? Why is this secure? They're not going to do it. Like there has to be explainability, a way for people to understand that. And again, coming back to the AI era, I think explainability is even more important. when we have, so many AI agents, LLMs, risk-based things, like making security decisions, triaging security things, if you end up not being able to explain that to end users or even to your stakeholders, it can pose really big challenges. So who are the people that participated in our survey? These were the security experts. Only 4% of them female. That was a bit sad. They were distributed across the world. You can see in green all the countries that participated. We announced this study on the Google. I was working at Google at the time as a Google blog post, and people just volunteered to spend their time and take this long survey for us. And that's the breakdown there that you see of jobs, and is the breakdown of like degrees. And it was self-reported. Anybody could take it. We did have some control questions, which is like we wanted to sort of check that people actually read the text, and that there was only one correct answer if you read the text, and that helped us like triage some answers out. But basically, it was based on whether people said they have 5 or more years of experience in security. And then for the non-experts, they were all from US, and we had a better distribution of male and female. And this part here with the demographics in the research world is incredibly important. I have seen many papers like get rejected because the demographics wasn't right, wasn't explained properly, that the sample wasn't representative for the conclusions that they would draw. And it's something that matters a lot. And I don't think you need the same rigor when you do research like in industry, but you should also keep in mind the fact that if you run a study or some questions in US, they are not necessarily going to apply to like users in India. That behaviors are different, and there are like differences across demographics, across regions, and so on. So let's see some of the results. So for security behavior, we asked, what are the 3 most important things you do to stay safe online? And this is what we got. What you see there with purple is the percentage of security experts that said they do one thing, and it's sorted by that. So most experts said they keep their system up to date, use unique passwords, use two-factor authentication. And if you look at the big black lines, like the one in the middle, use antivirus, visit only known websites, use strong passwords. So there are differences, in what experts and non-experts did to stay safe online, and then we're going to see in the perception of like security of different things as well. So let's look at this data a little bit different and do just the delta between the 2 lines. So to the left, we have experts with update your system, use two-factor authentication, use password manager. By the way, passkeys had not been launched back then. I do think it's again, coming back to my hate of passwords, I love passkeys, and I think if we were to rerun the study today, that would make it in. And on the non-expert side, things that maybe to me were a bit surprising. Use antivirus was incredibly popular. It made me think that security advertisement works. Change passwords frequently, something that I absolutely hate to do, and that I would never, out of my own will, do it for the sake of security. And visit only known websites, which made me wonder, well, how do you survive on the internet there? It didn't seem very practical to me. And we also asked to try to understand why users do different things, or why they think that something is secure or not. We asked a bunch of more questions about it, and what you see here is an example of a quantitative question where they had to select, I remember passwords for all of my accounts, most of my accounts, some of my accounts. And what you see here in green at the bottom is that way more non-experts than experts resorted to remembering passwords. Whereas what you see on the right side is that more experts were using a password manager. And we asked some additional questions to understand why. And that's sort of an example of then we combine this quantitative data with qualitative data, trying to interpret and explain the results. And we had experts say things like password managers change the whole calculus because they make it possible to have both strong and unique passwords. And this is one thing that both experts and non-experts thought you should do, and I think it's still true today. You should have strong and unique passwords, but how are you humanly capable of doing that? That is a different question, right? And coming back to the discussion about mental models, this is why I found this so fascinating. Because when asked why they don't use password managers and instead they remember passwords, non-experts said stuff like, I try to remember my passwords because no one can hack my mind. That is great, but we know you use the same password everywhere and it's already linked on some database. And honestly, like if we ask users to change a password, they're just gonna add a 1 at the end or an exclamation point. And also no other, when asked about password managers, they didn't quite trust them because no other application seems to be safe. So how can I believe password managers are? And this is where, this is, in my opinion, a strong example of where you can build a system that's really good for security, password managers. Yes, there have been breaches for like password managers as well, and some people worry about that. But when you look holistically, users are much more likely to get their passwords compromised because they use weak passwords and they use it everywhere than because somebody stole it from the password manager. But we can build secure systems if it doesn't, if we don't explain it properly, if it doesn't match the way people think about what is secure, like in this particular example, they're not going to use it, no matter how many experts they tell them to. And to me, that's a strong reason for doing studies on mental models, for trying to understand how people think about security and trying to align, your messaging and the systems you build to that. And for the non-expert behavior, use antivirus, change passwords frequently, visit only known websites. Coming back to the change passwords frequently, like I mentioned, one of my heroes has looked through all the security, usable security research and was able to really show that if we force users to change passwords, it doesn't result in stronger security outcomes. That an attacker, if they know, based on the research that was out there, if an attacker knows the previous user password, they are very likely to guess what is the new password. Because the coping strategies of users, when they have to have a lot of strong and unique passwords, is to have variations of the same password, where you add the 1, you add the 2, you change it a little bit at the end, and those things are also very predictable for attackers, and they can be guessed. So I've been super thrilled to see the recent sort of shift in compliance standards as well, and in the industry to stop requiring like forced password changes. So conclusions from those study, the non-technical users were using antivirus, saying you should use strong passwords, change passwords frequently. Whereas on the right side, the experts' attitudes were different. They were, some things overlapped, but some didn't. So we should, when thinking about security advice and what we promote, I think we should promote. The conclusion was to promote, keep your system up to date, update two-factor authentication, use password managers, because those were the things that people were doing less compared to experts. Now again, I think this one thing that I would add today is use passkeys. I love passkeys. They were launched back then, but something that absolutely I recommend, and that it helps with my hate for passwords. So now I've talked a bit about the different methodologies and what research looked like in my usable security in my life in academia. I've spent now 13 plus years working in industry, and yes, I'm still working on security systems, but with a lot maybe less focus on user research, since my main job is engineering and managing an engineering team. And one thing that I can truly say is that the same principles, sort of usable security, still apply. Those things about like understanding why you need to build things secure by default, to test things early, to yeah, basically to apply all of those things. They are still important. And in terms of methodologies, I still apply similar type of methodologies. However, it's a lot stricter. It's a lot less, how would I say, academic from the point of view that demographics don't matter as much. I can use smaller sample sizes, and even just talking to 5 users like gives me a lot of information about like what bugs or what things to fix. Another thing that I think is way more prevalent in industry, and that I was fortunate to do, is A/B testing. And A/B testing can be very powerful because you can essentially try different versions of your interface, and you can see how users actually react to it, and you can see what security warning or what security explanation works better. And we also use surveys a lot. So one of the things that I have really gained an appreciation for is the secure by default and what that actually means when building large-scale systems. And I think a lot more of my time that goes into that, into securing that pavement and like securing the things that are underneath. And a lot of my projects are on security infrastructure. They are on, things like paying technical debt, things that take a really long time to get to that minimum like usability improvement that you want to see. And many times also we know what the problems are or what the usability problems are, but it's, it takes that planning and engineering and the time to fix them. So definitely I gained a lot more appreciation for that secure by default and how challenging that is, or like why not many systems are, secure by default from the beginning. And thus for user-centered design, one really important lesson that I think it's, it's even more important in industry is involve real users from the start. And like, as soon as you have a prototype, as soon as you have something going, like put it in front of some people, test your assumptions, and it can be as easy as like, stopping someone on the hallway and asking for feedback. Designing based on actual workflows and mental models, I do still think it's very important, and we can see some examples of that later. And test with representative users throughout development. So I want to talk about a recent project that we have done on building an internal access group management system. And the story here is that we made a design, we implemented, we tested it early, but we got to a point where it was like a go or no go on the launch. And initially we had some assumptions, which is that you don't need or that you need UI to launch. So maybe let me jump to that. So we had one way to use this access group management system and add people to teams is to use the CLI. We had the CLI that is available, but the UI then was going to take longer to put out there. And we intended initially to launch only with the CLI. And now the problem is, when testing it with some users, some of our users were managers, engineering managers, and others were engineers. And we got, some feedback that, hey, it's not good enough. But basically, like, this is an example of where I think as an engineering manager, I get put into this situation of like, make a decision, launch or not launch today, wait for, I don't know, 3 more months to build the UI, or like do it with these things. If you launch something that's not good, sometimes you only, get one first impression, and then you sort of miss the moment. And that's one example where I put back my research hat and I said, I'm gonna make the decision, but not without data. Like, the only way to like really know is to go talk to your users. And I think many of the sort of usability designs, they are somewhat intuitive to us, especially when we are users ourselves. But so many other times, like they may seem obvious in retrospect, or we try to, make decisions without actually like basing it on real data. And that's where my research mentality sort of came in again. And in terms of like, how do I design a study for that? I think it's, again, it was much more lightweight. It was task-based, so it was more like the interface, like usability testing. And I created a little script and I asked people, engineers and managers, if they want to participate. And you can do this very quickly. You can use, recording. You can record your sessions, and then now you can use AI a lot to process that data. And even just 5 interviews like this can really reveal like quick pain points and wins and help guide decisions like that. So in our particular case, like one thing that that I found surprising, me being a manager, I tried to install the CLI and I thought this is unusable. But the reason why it didn't work so well for me is because I wasn't coding every day and I didn't have all the development tools set up. And so it was a lot of like churn for myself. And so I assumed that naturally people would like a lot more to like just go to the GitHub UI, click an edit button, and then add one person to that team file. And so basically that's it, I'm done. That was one of the tasks, add a person to a team. But surprisingly to me, when I spoke to engineers and they went through both flows, they liked the CLI better, because they said, and this sort of comes back to maybe like mental models, even if the CLI and the UI ended up creating the same PR and ending up being the same result, they felt that I'm sure that the CLI is doing the right thing because it's formatting everything right. But with the PR, if I do it directly myself, I'm not sure if I edited everything right. And for them, like the development environment was already there and it was a lot easier for them to set up. That's something that was a surprise to me as a manager. And when I told my team, who are engineers, they were like, duh. But I think that goes to show that many times we see our perspective and your users, they can be all different types or have different models, way to think about them. Another example here of things that, in retrospect, when someone said them, like they were obvious, but I didn't think about them before. I expected people to just go off the start of the user guide and follow the steps there. And someone just started using AI and asking AI how to do it. And the AI, someone is right there. That's the person. And the AI did not give the right answers. And I was like, well, duh, of course he's gonna use AI. Why would he go off the documentation anymore? But that wasn't obvious to us beforehand to be like, hey, let's try to see the AI answers. Is that gonna guide users to do the right thing? Let's look at it from that perspective. So we got a ton of really useful feedback in a very short period of time that then allowed us to say, okay, if we fix these things, we can launch early and then the UI can come later and, save a lot of get those security gains sooner, get that customer usage sooner, with very minimal effort. Like designing a research study in my academic life would take months of planning to make sure it's rigorous and you're doing the right thing. But in, for day to day and in industry, some studies take longer. It depends what you're trying to, to get to. But I encourage you all to, apply all of these methodologies in your day to day. So a few takeaways. You can design your own usability studies. Please think of yourselves as researchers. Examples could be, when you have a process, a security system that doesn't work so well, identify your users, think about what are the mental model questions. You want it to be more exploratory, or do you have specific things that you can quantify and then you can just send surveys out? And you don't need to be rigorous about it. And also with AI today, you have your own research assistant, basically. Please leverage that, right? It used to take me much longer to come up with questions and make sure that the survey and the design is done right. Now you can just use AI to synthesize results, but also you can use AI to design your studies and to run things very quickly. Also in my research life, I used to spend after doing many interviews, there was a very specific, and it's still being used, coding methodology where you go back to the qualitative data and you have a code book and you see how many times did people mention passwords and how many people said this, and then you have to sort of add all of that up and summarize. Now AI is very good at that, especially for when you're not sending your paper to a peer-reviewed conference, you can get those surveys and you can have AI summarize the findings really quickly. Also, recording sessions so you don't miss notes. It's something that I find very valuable and that you can go back to later. So one maybe other practical piece of advice that I would recommend, there was this paper also from a while back on helping engineers design neat security warnings. Whenever it's a framework, basically, it says that security warnings should be necessary, they should be explained, they should be actionable and testing. I think some of the worst things you can do is show a security warning that people have no idea what it means, what to do about it, that maybe does the wrong thing, and that it doesn't provide that clarity and it's not actionable. And I think this still is so relevant today, and it's relevant to anything you build for security. One thing that maybe I would change, where I would start to think about now, moving into the era of AI, if engineers are not the ones building systems anymore, or you have so many AI doing the coding, is it time to teach the AI agents these principles and to teach your AI agents what security warnings are? And that brings me to the last part of my talk. And as I said, full disclaimer, I don't have the answers for what usable security looks like for AI. We're barely starting to understand what AI means, and things are evolving super quickly. But I did think it's important to address that and sort of reflect, well, if the world is changing, then how many of the things I still said are still valid? If you're not the one building the systems, perhaps you have a bunch of AI agents doing it, then maybe they know it all, right? Maybe they already know how to do things secure and you don't need to worry about it. Well, so let's go back to what's new. With AI, we have many more applications that are vibe coded. We have many more applications that are being created, and that is great. But many of them, given the sheer amount of code that's written, there has been no users that went through and properly understand all the security choices. And you can assume that the AI agents will make good security choices. It's not always the case. We've seen, examples of private keys for the backend database being stored in the client-side JavaScript. So basically, you're making it available to everyone to be able to read anything in the database. That's something that AIs can make big oversights like that. And I think that makes security even more important. It makes security even more challenging, given how fast new applications are being built and how hard it is to keep track of everything. It's also made it a lot easier for attackers to vibe code incredibly sophisticated campaigns and to find vulnerabilities and to exploit them. And for decades now, we've had a lot of passwords databases being leaked and sitting there, and we're already seeing, evidence of attackers starting to use AI agents to really exploit those password databases and to do data exfiltration. So their capabilities have really increased. And also where for some things before they had to know how to code, you see people attackers that have no prior coding experience, just vibe coding everything and being able to do things that would have taken months of resources and dedicated engineers before. And from the user's perspective then, as AI agents do so many more things and they get access to so many more things, I believe the access control problem is just exploding. It's just now there are so many decisions for users to have to do on whether I allow this, I grant this, and it's very likely that it's going to end up in just warning fatigue where every time you ask the user, you approve, yes, I approve, I don't understand, like just, move on and keep going. And those are really usable security challenges, and we have to rethink about how to address them then, because you can't have the user like reviewing every prompt anymore, but it's still very important to have, those neat warnings and informed consent. And finally, another thing that I want to call out is that it's harder to understand some of the security decisions when they are made by AI or they are made with AI, but explaining them and the explainability of like why a security decision was made or what a security system does is even more important than before. So with all of those things changing, the usable security principles still apply. It is my main belief that they do remain, that all the the things we talked about, the good practices, they are very important. And I think in order for for these systems to be built right, just like engineers still need to know how to code, or the principles of like how do I build systems in order to guide AI and to verify if AI did the right thing. I think that's also the case for usable security. We need to continue to understand them and to help AI agents. But the context does shift a little bit from where before, like the focus was like help the users do the right thing, not make mistakes for security. The world has become more complicated, right? And so now humans have to delegate safely to AI. Usable security is going to mean different things, and it's probably not always going to be decisions made by humans, but decisions made by humans together with AI agents. And so now imagine you're that pedestrian walking on the sidewalk, and you could only go from like a couple of blocks before. With AI now, you can go 100 times more blocks, let's say, because things are just moving so much faster. But if at every block you have a security warning, that does not scale, right? So I think we need to also think about how do we scale systems to account for human input where we cannot like scale at the same time. So I think security warnings must be more automated. There should be an oversight, and an interesting idea there is to use perhaps an AI agent that can make decisions for security, or that can oversee other AI agents, but it's on behalf of the user, and knows like what kind of decisions to surface to the user and which ones are low risk, and so to just move on. And this is where I just wanted to say a couple of thoughts on the safe mental models. Part of my initial research during my PhD was how do people think about cloud, and it was this new concept, because all of my data used to be on my laptop, and now it's all over the cloud. And so we had no idea. Do they think it's safe? Do they think it's still theirs? And I think the use of AI, like it's a new paradigm shift. And I think making sure that users understand what models actually do, what access to their data they have, what kind of privacy guarantees they have when they talk to LLMs about and ask legal advice, medical advice. What are the implications of those things? It's incredibly important, and I think this work on mental models, or making sure that expectations are meet reality, is even more important in AI. And one other thought. There's a concept, and it's happening for AI to be adversarial, right? So far, maybe you've used security systems, and the expectation was that you click buttons and you set up the right policies, and it's deterministic, and it's going to be to what you set it up. Now, if you use an AI agent instead, and this AI agent is starting to blackmail you, or starting to have a different, a different intent, there is a whole new dimension of like adversarial AI. And on top of that, there's also, many advances in like biometrics, in deepfakes for biometrics, all sorts of attacks. And the previous advice that we had for users to be vigilant, to not fall for phishing, to look for spelling mistakes in the phishing email, because that's how you can tell if it's a legitimate email or not. It all falls apart, right? Because with AI now, phishing emails can be perfect. So I really think we need I believe we should think not just about humans, but now humans and AI together. How can they team up to make usable security? And in terms of methodologies, I think all of the usable security methodologies still apply, but in my mind, longitudinal studies become even more important, because if you just do interface testing, you bring some people, they try like an LLM agent once, it does one result. That's going to be probably a very different experience to like next day and 5 weeks later when the user uses it for the same purposes. And AI agents, also technology changes so fast and user behavior changes. So I think we'll see more shift towards like longitudinal studies. And this is my last slide. I was just thinking back to that first slide on usable security recommendations and how would I maybe adapt them to AI, or what would I add for AI. As I've said, secure by default, I still think it's very important. But what that means, I think it has a new interpretation. I think we need to build in usable security guidelines to teach agents from the beginning. When you start writing prompts to build a new system, you should already be thinking about usable security, and you should already be thinking about how do you teach your agent to think about that as well. Align system with users' mental models, like I've said, super important. Have to design for AI speed and involve users in decisions based on a risk-based process, because it's not going to be possible to ask for user input on everything. Provide transparency. Upload that neat warnings paper into your LLM, into your AI agent, and have them read it, right? Like teach your agent. And when we used to say involve real users in design and testing from the start, one crazy thought is that your users are not necessarily going to be real people anymore. Your users may be AI agents, because you're building a system that's used by other AI agents. So I don't know how you do user studies on that, but I think we're going to figure it out. So thank you all very much.